Last class you learned about linear inequalities, and now we're going to combine linear inequalities back with systems of equations to make systems of linear inequalities. So this is what a system of linear inequalities might look like. Just like a system of equations was two or more lines at the same time on a graph, a system of linear inequalities is going to be two or more inequalities graphed at the same time on a coordinate plane. Now, when we have a system, we're not just looking for a singularly shaded region to find our solution set. When we're talking about solutions to a system of inequalities, we're looking for what I like to call the supershade. Okay, there are four regions created on the graph you see on your screen. There's region 1, that's blue. There's region 2, that is purple-ish. There's region 3, that is red. And then there's region 4, that is blank. Which one of those regions do you think all of the solution set for this system occurs in? Which one is the supershade? Yeah, right here in the purple one, where both of the lines overlap, that's going to be my solution set to this system of inequalities because it makes both inequalities true. It's where both shaded regions show up. So some examples of what might be considered a solution to this system would be like this point right here. That is a solution, so we could say 2, 5, which is that point, is a solution. We could also say that this point right here is a solution. That's the coordinate 0, 3. So again, there are many solutions to a supershaded region, many solutions to a system of linear inequalities, which is where the graph overlaps both shaded regions. Anything not in those shaded regions is considered a non-solution. So anything in the blue region only, like -4, 2, that is not a solution to this system. So no way. Anything over here in only red, like 5, 3, is not a solution. Anything on a dashed line, even if it looks like it's part of the shaded region, remember dashed lines are a no-go. So 2, 3 would also be a non-solution. And anything in the blank region by itself, that's definitely not a solution to this system. So we could also include -4, -3 on our list of non-solutions. There are plenty of other examples of solutions in the purple or non-solutions in any of the other three regions on this graph. But what we're interested in is where those lines overlap, where the boundary shadings overlap. Now, when we're doing this lesson, I want to make sure that you're using test mode only. We practiced this in class the other day, but remember, anytime that I need you to get onto Desmos, at this point now, I need you to always make sure that you are getting on to test mode. We need to be practicing with the one we'll get on our DCP, on our chapter test, and on our STAR test. So the steps for that are desmos.com/practice. Yes, you need to type all of this in so that you include the practice part. You will choose the assessment and type in Texas STAR so that you have Texas STAR in the corner of your Desmos screen. Let's make sure we do that. Let's also review for a hot second all of the vocabulary we talked about with linear inequalities because it's going to come back to haunt us. Okay, when we have a less than sign, less than is your left hand. It is also going to be shaded below with a dashed line. When we have greater than, that looks like your right hand, we're going to be shading above with a dashed line. Less than or equal to is your left hand again. This one is going to be shaded below, but have a solid line because it is equal to it. And greater than or equal to is going to be shaded above with a solid line. Those are things you super need to know today to be successful. All we need to be able to do is graph systems of inequalities and then find solutions to them. So let's look at this first example here. It says to graph this system of inequalities. Well, I know that if I'm graphing something, I need a slope and a y-intercept. For the first line, I'm going to do this one in green. I know my slope and I know my y-intercept. The y-intercept is 4 and the slope is -1. So I'm going to go down 1 over 1. I'm going to grab my straight edge and I'm going to shade below but draw a solid line. That's what less than or equal to tells me, is that it's below and solid. So I'm going to make a solid line. Woohoo! and I'm going to shade in below it. Doesn't have to be perfect shade, but we're going to shade in below. All right, that's the solution set for the first inequality, but we have a system of inequalities, which means I need to also graph the second one. But it is not written in a form that I can directly solve right now, so I'm going to need to solve this equation for y. I'm going to take the 2x to the other side. It becomes positive 2x. This is 3y greater than 2x minus 6. Divide both sides by 3 everywhere. And I would have y is greater than 2/3 x minus 2. Cool. So this is actually the equation that I'm going to graph. All right, so we start at -2, and I'm going to go up 2 over 3. And then since this is greater than, that means I'm going to shade above but with a dashed line. So when I put my straight edge down, I'm not just going to draw a big old straight line. I'm going to make sure it is a dashed line. So right here I come in with a dashed line, meaning it has a lot of gaps in it. Ooh, drop my protractor. And I'm going to shade in above this graph. Everything above the line gets shaded in. Now, there are 4 regions created, but only one of the regions contains my solution set. Is it going to be region number 1, region number 2, region number 3, or region number 4? Which one has my solution set? Yeah, region number 1 is my solution set because it's where the colors overlap. It is the super shade. Those coordinate values there would make the x and y true in both equations because it's in both shaded regions. So here's what a question might look like that we could ask you. We could ask you to graph the system of inequalities. Notice it says make sure you're using Desmos test mode, and then determine which ordered pair represents a solution to the system. Now, if you try to type number 1, the first equation, in on Desmos test mode, it's not going to work. Remember, in Desmos test mode, it will not let you graph everything. But if you change that to an equal sign, it will graph a line for you that starts at 5 and has a slope of 1. You need to remember that when you're sketching this onto your paper, that you need to use a dashed line and shade above it, because Desmos will not do that for you. You have to remember that important part of this lesson today. So we use a dashed line. Here's my dashed line. And I'm going to shade in above it. Easy. So you can use Desmos to check and make sure that your lines are going the correct direction, but you also have to remember how to shade and what kind of boundary line to draw. If we tried to graph this one right away, Desmos test mode and our brains would say, something's wrong. We need to solve for y first. So I'm going to take that x to the other side. It becomes -x, and I have -4y less than or equal to -x plus 16. I'm going to divide by -4 everywhere. And when you divide by a negative number and you're using inequalities, your spidey senses need to start tingling, because when you start dividing by negative numbers with inequalities, you actually have to flip that inequality sign over. So anytime you divide by a negative number in front of y, you flip that inequality sign. Just change the direction the mouth is open. This would be y greater than or equal to 1/4 x minus 4. Okay, this is the equation that I'm going to be able to graph. You could type the regular version of this. Okay? If you type this into Desmos, nothing would happen, but if you go ahead and type it with an equal sign instead, Desmos will help you out with what the line will look like. The line says start at -4, go up 1 over 4, so it's going to look something like this. But since you have a greater than or equal to sign, that is going to be graphed above with a solid line. So we can take our protractor or our straight edge of sorts, and we can draw a straight line through all of the coordinate points. Wasn't great. And again, we're going to shade above. Now the point here is we need to determine which of these ordered pairs in our answer choices is a solution to our system. Let's go ahead and plot all of the coordinate points on our graph. You can type these into Desmos if you wanted to. You can take each and every one of them and write them as a coordinate into Desmos, and it will plot them for you if you need assistance. So here's the first one. 5, 0 is right here. Here's A. Now A is on my dashed line. Things that are on dashed lines, are those part of our solution set? No. We get rid of it. Number B says -3, 0. That's right here. Is that in my super shaded region? No. 4, -5. 4 and -5. Is that number C in my super shaded region? No, definitely not. So we really hope D is, now that we've eliminated all the rest. We're going to go over 4, up 4. Here's answer choice D. Is that in my super shaded region? Absolutely. We would choose answer choice D here because that answer choice appears in my shaded region. Now remember, on Desmos, it won't show you the shading, but it will give you the lines if you know which direction you should shade. Let's look at the last one here, number 2. It says that the inequalities are y greater than 2 and x less than or equal to -3. Now remember, Desmos won't graph these unless you put an equal sign. So if you needed assistance graphing these, you could actually type in y equal 2 and x equal -3, and Desmos would graph just the lines for you. You have to remember the inequalities. For the y greater than or equal to 2, remember that's above and solid. And for x less than or equal to -3, remember that's below and solid. So if we graph the equal versions of them without the inequalities, we're going to end up with a Hoy line at 2, which means that it's horizontal, solid line. And if we type x equal -3 into Desmos, we're going to have a Vux line, a vertical line, that crosses the x-axis at -3, and we can make it solid. We just have to remember what above and below means. Well, for the y greater than or equal to 2, that one's easy. Okay, we can just graph above it. So all of this is in my super shade, or in my shaded region for y greater than or equal to 2. But if I was trying to make sure I understood how to do x less than or equal to -3, and I say below, there's no below a vertical line. So we actually have to think here. Are numbers less than -3 on the left side or on the right side of this line? Yeah, numbers are less over here. So we're going to shade in where it's less on the left. That's technically below this line. All right, we have our 4 regions. Let's check out our answer choices. Answer choice A is 2, 2. That is exactly right here. Here's answer choice A. Is that in my super shaded region? No, it's only on the purple line, which means it works for the purple graph, but not the green. B says -5, 3. So I would go to -5, 3. Here's answer choice B. That looks pretty good. We're going to hang on to answer choice B. Answer choice C is -4, -1. Is that in my shaded region that I want? No, it's only in the green shaded region. That's only less than the green one, not greater than the purple. And 1, 3 is right here. Is answer choice D in my super shade? Nope. Which means answer choice B is my solution, or is in the solution set for this system of inequalities. So ladies and gents, we are combining what we learned about systems of equations when there's 2 equations on a graph at the same time with what we just learned about linear inequalities with the shading. You have to remember that blue chart I have highlighted in the center. That's going to be such important information for you so that you know about the boundary line and which direction to shade so that you can find our super shaded region when we're doing a system of linear inequalities. See y'all in class.